All right. Hello, pre-algebra students. This is going to be your part 2 lesson on solving multi-step equations. To get us started with this, we've got our two do now questions to warm up our brains. You want to go ahead, pause the video, and try these two problems now. All right, for this first equation here, you would have wanted to start off by distributing, so multiplying the 2 with the n and the 2 with the 5. When you finish solving this equation, you would get n equals -6. For this other one here, you should have gotten x equals 1. You would have wanted to combine the x and the 3x to get 4x as your first step, and then continued on solving. Now that we are all warmed up, we are ready to go. Remember, we are going into part 2 of this lesson on solving multi-step equations. We are going to start off with our first example, which looks like this equation here. I just want to pause and looking at this equation, ask, what do you notice? How is it similar to some of the equations we've already solved? What's different about this equation compared to all the equations we've solved at this point? Go ahead and take a moment and answer those questions to yourself. So when I asked this in class, some of the similarities students see is we've still got a variable in our equations, right? We've got x. Some students notice there are still constants. They might notice that there's something you can combine. There's like terms in this. The big difference between this equation and all of the equations we've solved so far is when you notice where that equal sign is, it's right here in the middle. And lots of times I like drawing that line down at the equal sign. If you do that, you notice that the variable, the x, is on both sides of this equation. We've got an x on this side, and we've got x's on this side here. That's going to be the biggest difference comparing this equation to all the other equations we've done so far. Now, the goal of solving equations is the same. Remember, our goal is to figure out what that variable equals. So my answer, once I finish solving this, is going to say x equals some sort of number. And that's important. Notice our answer has x on one side of the equation and a number on the other side. So what that means is as I'm solving this equation, at some point, I'm going to want my x only on one side of the equation. That's going to be a real big part in this. The way we would start this equation off is very similar to the way we were starting our equations yesterday. I want to start by seeing if I can simplify something. I'm going to draw that line at the equal sign, a little crooked, but it's good. Looking at both sides of this equation separately, do you see anything we can simplify? Well, on the left side, I've got 4x minus 1, and we know we can't subtract those because you can't subtract a variable and a number. But over here on the right side, I see there are two like terms. I can combine the 5x and the 3x, and when we do that, we get 8x. Now, our next step here is going to have to do with that idea of we only want our variable on one side. I right now have x on this side and x on this side, and I don't want that. So I need to get rid of or cancel one of these x's. We can choose to cancel the 4x or the 8x. It does not matter which one you choose. For example, if I wanted to get rid of my 4x, in order to do that, since it's positive 4x, I would need to subtract 4x on both sides. When I'm subtracting, 4x minus 4x would give me 0. It would cancel out. And then over here on that right side, the 8x minus 4x would leave me with 4x. Notice I'm bringing everything down. That 1, make sure you get that negative sign with it. So it would be -1 equals 4x minus 9. At this point, it goes back to those two-step equations that all of our equations seem to go back to. At this point, I'm looking at the side with my variable. I need to get rid of the 4, and I need to get rid of that -9. We will start with that constant, that -9. The opposite of -9 is +9. When we do that, -9 plus 9, that gives me 0. Over here on the left side, a -1 and a +9 would give me a +8. Instead of thinking -1 plus 9, you could also just think 9 minus 1 and get 8 that way. But we're left with 8 equals 4x. Our last step, since 4x is multiplication, it's 4 times x. I want to do the opposite. So instead of multiplying, I got to do this part. I got to divide by 4 on both sides. And when we do that, 8 divided by 4 gives us our answer, which is 2 equals x. That means in this equation here, if I were to replace x with 2, it would make these two sides equal. We could even go ahead and do that. If I put a 2 right here, it would say 4 times 2, which gives me 8. So on that left side, it says 8 minus 1, which we know is 7. Over here on the right side, if I put a 2 here, 5 times 2 is 10, plus 3 times 2. 3 times 2 is 6, and then that minus 9. We already said the left side here equals 7, and then on the right side, 10 plus 6 is 16, and 16 minus 9 is also 7. So we see that both sides are equal. So the goal of this is the same. It's that idea of trying to figure out what that missing number would be to make these two sides equal. Like I said earlier, the key difference with this equation compared to all the other equations we've done before is now we've got variables on both sides. So a key takeaway from this problem is that when you are solving equations, you need your variable on one side. I chose to cancel out that 4x, and that left the variable, my x, on the right side of the equation, and then I was able to finish solving. Now, if I go back to that line right there, I just copied the same thing. Earlier I said it does not matter which x you choose to cancel. So I chose to cancel the 4x, but maybe you're at home saying, well, I wanted to get rid of 8x. What would that look like? Well, if you wanted to cancel the 8x, the next step here would be similar. Just instead of subtracting 4x, you would want to subtract 8x. When you do that, 8x minus 8x gives you 0. It cancels out. And then here on the left side, the 4x minus 8x gives you a negative 4x. Again, it's just like our favorite thing ever, the two-step equation we're going to solve. Notice it looks different than what we had over here. And another difference is now our constant is that minus 1. So I would do the opposite. I would add 1 on both sides. That gives me the negative 8. So again, this looks different than what I had before. But that last step, we've got a negative 4x. So I want to divide by negative 4. And once we've done that, negative 8 divided by negative 4 gives us, it's hidden, but it's there. There it is. X equals 2. So the work in between might look different depending on which way you decide to go. But that final answer, 2 equals x, x equals 2, that final answer is the same thing. Which is why you can choose how you want to do this. I personally, my personal preference, I went for the 4x just because I know if I were to subtract 4x, it would leave me with a positive number. Whereas if you subtract 8x, it gives you a negative number. You get negative 4x. And I personally, I think similar to a lot of you, like positive numbers and not negative numbers. But that said, there's a lot of people who like having their variable on the left side of the equation. You know, we're used to seeing x equals 2 and not 2 equals x. So a lot of people who like to have that variable on the left side like to cancel out the 8x instead so the x stays on the left side. It's really just a preference. It's up to you what strategy you want to do. And hopefully you can see from these two examples here that you're left with the same answer regardless of how you solve it. I think we've talked enough about this one. So I'm going to move us right along. Let's get rid of all that. You can see what's coming up. That's not the one we're going to do next. We're going to come to this one here. It's got decimals in it, but the idea of solving this is the same. I'm actually going to have you go ahead and try this first before we go through it. So go ahead, pause the video now and try solving this equation for C. All right, so similar to that last problem, we have variables on both sides of our equation. So our first step is going to have to be to cancel one of the variables. Now, I just a moment ago was saying it doesn't matter which one you cancel, but here there is definitely an easier one to cancel. If I wanted to get rid of my 4.3c, I would want to subtract 4.3c on both sides of the equation. The the struggle, I guess, with that is if you do that, it's going to leave you with c on this side of the equation. We've already got 6 on side of this side of the equation. On the other equation, if I were to subtract that 4.3c, I'm going to have nothing left over there. So it would equal 0. There's nothing wrong with that, but you're giving yourself extra steps. Instead, because the number is on this side of the equation, the constant is on this side of the equation, I'm going to say, let's get c on this side. So instead of subtracting 4.3c, I'm going to choose to subtract 8.3c. If I do that, it cancels c on this side, so I'm left with the number here, and then the c, or my variable, on the other side of the equation. When I subtract 8.3c, that leaves me with 6 equals negative 4c, which is nice. It got rid of that decimal. That's not always going to happen, but it's a fun thing about this one. And then our last step, this is multiplication. So I want to divide, grab my pen, divide by that negative 4 on both sides. Now, when I go to do that, negative 4 divided by negative 4 equals 1c, or just c. So those negative 4's cancel out. On the other side of the equation, 6 divided by negative 4. What is that? You might notice you can't divide 6 by negative 4. So what that means is our variable c is not going to be a whole number. It's going to be a fraction or a decimal. And that is okay. A lot of students, when they get to an equation that's got a fraction or a decimal answer, they feel like they've done something wrong. Oh no, I couldn't divide this. There must have been a mistake. No. Remember, your variable can be any number. We're just trying to figure out what number needs to go here to make those two sides equal. And that number can be a fraction or a decimal. It does not mean you are doing anything wrong. In this problem, it just happens to not be like a whole number. It's going to be a fraction. When it comes to these fraction answers, if we're going to leave it as a fraction, we want to make sure we can simplify it. So I notice both 6 and 4, we can divide both of those numbers by 2. So I could go ahead and do that and say, if I wanted to answer it as a fraction, I could say negative 3/2. Notice I just brought that negative sign out to the front. That's where you would normally see it, since you're saying negative and then saying the fraction negative 3/2. If you wanted, you could also change this to a decimal. So if you divide negative 3 by 2 to get the decimal form, it would be negative 1.5. Either of these are good. Again, it comes to a personal preference, unless the question said, like, give your answer as a decimal. I personally would probably put it in decimal form just because the equation already had decimals in it. And if the equation had fractions, like this fun one we're going to do next, I'd probably leave it as a fraction. Again, just like a personal preference, unless the equation or unless the problem said to do something different. Speaking of this, I'm sorry. Speaking of this next problem here with fractions, look at this fun one that we're going to do next. When it comes to solving this equation, one way you can solve it is doing the same thing we were doing over here and go in and say, okay, well, we've got x's on both sides, so I need to cancel one of the x's. Let's subtract 3/4 x on both sides. And then you kind of open up your world to doing math with fractions, adding, subtracting, multiplying, dividing fractions. That is definitely a strategy to do this. Some people feel very confident in their ability to do math with fractions. And if you are one of those people, you can go about it that way. Another strategy to solving this involves a step at the beginning that gets rid of the fraction. And so, because I know a lot of us, even if we are confident in our ability to do math with fractions, we might not like doing math with fractions. So that's going to be what I'm showing you here. Now, the strategy you can use to change the equation so that there's no longer fractions has to do with what the denominator of the fraction looks like. The denominator is the bottom number. One way you can read this fraction is like 3/4, 5/4. Or another way you can read this right here is 3 divided by 4. Now, if I wanted to get rid of the fraction, just like what we're always doing when we're solving equations, I could do the opposite. The opposite of dividing by 4 is multiplying by 4. So if I wanted to get rid of the fractions in this equation, I could multiply the equation by 4. Now there's a couple different ways you can show that. Notice I said multiply the equation by 4. Kind of goes back to whatever you do on one side, you do to the other. If I wanted to do that, I could show it by saying I want to multiply the entire equation by 4. Whatever I do on one side, I do on the other side. You can write it like that. You could also write it individually. So instead of saying I'm multiplying this entire side by 4, you could just go in and show I'm going to multiply everything by 4. So I'm going to multiply this term by 4 and multiply this term by 4. I think this is usually the most helpful way. But the idea is whatever the denominator is, here it's a 4, we want to multiply every part of the equation, every term by that number. When you do that, what happens? Well, for this first one here, we've seen that when you're multiplying a whole number by a fraction, you're multiplying like 4 over 1. So if we do that, 4 times 3 gives us 12. And then 1 times 4 gives us 4. So we're left with 12 fourths x. Well, 12 divided by 4 is just 3, so we're left with 3x. What I want to point out that's happening here is those 4s are just canceling. The reason we are multiplying by 4 is to get rid of that fraction. So you're multiplying by 4 to make those 4s cancel. So you can do all of this math, or you can just say I'm multiplying by 4s to get those 4s to cancel, and I'm left with 3x. Same thing over here. I'm multiplying by 4 to get those 4s to cancel. So here I am left with 5. And then this last part, you've got your 4x times 4. There's no fraction to cancel. So we're just going to go ahead and multiply this and say 4x times 4 gives us 16x. And so when you've done all that, it looks, oh, look, okay, there it is. It's going to look like this. Those 4's canceled out to give you 3x. Those 4's cancel out to give you a 5. And then the 4x times 4 gives you 16. If the denominator of this fraction was a 10, you'd be multiplying everything by 10. If it was 17, you'd be multiplying everything by 17. We're just using whatever that denominator is to multiply to get rid of the fractions. This is usually the problem that's makes people kind of pause and think the most. So feel free to rewind the video like 2 minutes back and listen through it again. Just make sure you're following along. But I think this is a really great strategy to use just because it gives you an equation at the end that doesn't have fractions you have to worry about. So you could probably take over from here if you wanted to. We've got variables on both sides, so similar to those other equations, we want to get the variable to one side. So I'm going to subtract 3x on both sides. When I do that, it gives me 5 equals 16x minus 3x, which is 13x. And then our last step, I want x all by itself. So I need to get rid of that 13. This is multiplication, so I'm going to do the opposite, which is division. I'm going to come in and divide both sides by 13. When I do that, those 13s cancel out. On the other side, 5 divided by 13 is not something that divides nicely, so I'm going to leave it as a fraction. You could have also changed it to a decimal. But like I was saying earlier, since the equation has fractions in it, I personally prefer just to leave it as a fraction. Ta-da! Like I said, I know this one look at all this red. It definitely looks crazy. But I do think it is a good strategy, especially if you're not feeling super confident adding, subtracting, multiplying fractions, all of that. Like I said, though, the other strategy to doing this would be to actually do the math with the fractions. So you could have started off by saying, well, I've got x's on both sides, so I want to subtract one of my x's to get my variable to one side. In this example, let's say we wanted to subtract 3/4 on both sides, then you would have to do 4 minus 3/4. In order to do that, I would change 4 to 4 over 1 and then make sure they have a common denominator. 4 over 1 is the same thing as 16 over 4. So 16 over 4 minus 3 over 4 gives you 13/4 x. And then you're still left with that 5/4. At this point, you still have fractions on both sides. You could go in and say 5/4 divided by 13/4. But I still think this idea of multiplying by 4 on both sides to cancel out the fractions would still be helpful. And then voila, you're left with the same answer. Like I said, if you are confident in your ability to add, subtract fractions, then feel free to keep doing it this way. But I did want to show this as an option, or at least another option to solve. I've talked a lot, so it is now that time for you to try one yourself or try two yourself. Go ahead, pause the video, try solving both of these equations now. Okay. I did want to talk about the second one before we kept going, just because, like I said, I've taught this in person before, and this is usually the one that makes people stop and think. If you are using that strategy we showed earlier about multiplying to get rid of the fraction, the number you would want to multiply on both sides by is 2, which means you want to come in and multiply everything on both sides by 2. When we do that for this first part here, those 2's would cancel out, which would just leave us with the 3x. Remember, you're multiplying everything, whether it has a fraction or not. So here, those 2's would cancel. But when I multiply the 2 by 3, because I'm distributing, right, that would give me a 6. So I'm going to say plus 6. And then on the other side, it'll be real similar. When I multiply my 2 by the 5/2, those 2's cancel, and I'm left with 5x. And then the 2 times the 1 just gives me a 2. Ooh, it's so annoying to write this with your finger. Okay. After that step, it's a lot easier. Since there's no fractions left, your answer would be x equals 2. Yes. Oh, and I should have said over here, the answer for this one is 3. N equals 3. Continuing on, there is one last one for you to try. And that last one says, show 2 different ways you could solve the equation 5s plus 23 equals 2 times s minus 2. Have at it. All right. We ask questions like this just because it's good to know multiple methods, especially, like at some point you'll be working with other classmates again. And, everyone has their own strategies to solve things and everyone has something to bring to the table. So it's just asking you to kind of explore that and look at different ways you can arrive at the same answer. One way for this would be starting off by distributing that 2. And then if you choose to cancel your 5s, it would give you negative 3s on the right side. You could add 4 on both sides. That would leave you with 27 equals negative 3s. This is multiplication, so we would want to divide by negative 3. Pretend there's a division line right there. And then 27 divided by negative 3 gives you negative 9. Another strategy you could use is still starting off by distributing, but instead of canceling the 5s's, you could cancel the 2s. That would leave you with 3s plus 23 equals negative 4. Here, you would want to get rid of your constant, the 23, by subtracting 23 on both sides. That would leave you with 3s equals negative 27. And then similar to before, this is a multiplication problem, 3 times s. So we want to do the opposite, which is division. Again, pretend there's a division line there. But negative 27 divided by 3 gives you negative 9. And of course, there are more methods. You might have done something different than I did here. But what we do expect is no matter which strategy you're using to solve, you should be getting the same answer. So notice both times we got negative 9. There is one last type of problem I want to look at, and that is this one here, where notice you've got multiple terms for the numerator of your fraction. Before, if I skip back to, oh boy. If I skip back to this one here, it was just a fraction as a coefficient or a fraction in front of a number. Now we are looking at, sorry, I didn't think this through. There we go. Now we're looking at like one big term that has, it's one big fraction, right? It's got multiple things inside the fraction. Do you have an idea what we would want to do to solve this? Well, it's similar to what we were seeing earlier. If I wanted to solve this equation, I would want to start off by getting rid of this fraction here. And that fraction says divided by 2. In order to do that, similar to before, I'm going to do the opposite. And the opposite of dividing by 2 is multiplying by 2. When I do that, those 2's will cancel out, just like before, because we've got a multiply by 2 and a divided by 2. They're opposites. That just leaves me with the 3x plus 5. And then on the right side, 16 times 2, which gives me 32. Once you get to this point, you guys are really great at taking over from here. It's a two-step equation. So we want to get rid of our constant, which is that plus 5 with a minus 5. 5 minus 5 gives me 0. I'm going to jump over here. That 3x comes down, and then the 32 minus 5 gives us 27. Our last step is, in order to get x by itself, we need to get rid of that 3. This is multiplication, so I want to do the opposite, which is division. And then the x, and then the x equals 27 divided by 3, which gives us 9. In those problems before, I showed like multiple strategies you could use with those fraction problems. You didn't necessarily need to do this trick, but for this one here, we can't do anything until we've gotten rid of that fraction. Our constant is a 5, but you can't subtract the 5 because it's a part of this fraction, and you need to get rid of that divided by 2 first. Another thing is, because all of this is divided by 2, another way you can think of it is there's like parentheses right here, and we have to get rid of that divided by 2 before you can do anything on top of the numerator. That's my last example. You've got this one here for you to try. All right. In order to solve this one, you would have wanted to multiply by that denominator 4 on both sides. When you do that, that gives you 8z equals 4z minus 16. And your final answer for that would have been -4. That is all I've got for you guys. Thanks so much for watching. Bye.